somebody was connected. So if you remember, our wave function looked something like this. Is this visible now? Yeah, it is. Okay. So yeah, when 0 is less than x is less than equal to a, and it's equal to 0 otherwise, right? And what I had told you first, that we should essentially normalize. All right. So the normalization, if you remember, essentially what did we do? We were between, you can actually do it from minus infinity to plus infinity. Your wave function mod psi x 0 dx should be equal to 1, correct? Yeah. And the basic thing is, of course, this implies that you essentially need to do it only between 0 and a, because that's the only place where the wave function, oh sorry, yeah, only place where wave function has some value, right? And you will get essentially your mod a square, and then you get essentially your x square a minus x square, all right, dx is equal to 1. And when you solve for this, okay, so Chetan tells me that we finished this last time, you should get the value of root of 30 by a power 5. Okay, so this is your value of a. Okay, so I hope everybody kind of saw sense in this. Now what do? We essentially go ahead. Oh yeah, I think we were trying to solve for the CNs, right? So just 1 second. Yeah. So we were trying to solve for the CNs, and how does it work essentially? So we will now then write our psi of x t as equal to summation over n is equal to 1 all the way to infinity. And then we have your Cn. Uh, these are your eigenstates of the infinitely deep square well, all right? And then e to the power of minus I by h cross, you have ENT, where these are the eigenstates and these are the energy eigenvalues, right? Right. So now if you remember, how do we get the Cn? I think I had explained the logic last time, that you will have to do essentially sine star, okay, x, and this of course from 0 to a. This should give you your Cn, all right? And so thereby just let's start putting things down. 0 to a, this is root of 2 by a, right? And then you have sine of n pi x by a, correct? And then you have your basically you're going to put in this particular function again. So let me just put it. So here now our a is nothing but 30 divided by a power 5, and then you have x into a minus x dx. Okay, so what do we get now? So kindly do this yourselves, all of you. I don't think we did it last time, so start working on it so that you can do it with me and you can see whether we are coming up with the right answer. Chetan, of course, has done it, so he's going to get a bit bored, but he can oversee whether I'm doing correct things or not. Right, Chetan? What happened? All of
You
you?
will be doing correct.
I'll be doing correctly. I'm not too sure, Chetan. I wish I could be. I had your confidence. I don't. Okay. I make a lot of silly errors. Okay. I shouldn't say such things. Okay. So then this will be what? This will be like 60 by a power 6. Okay. Which I will bring out. So you'll have it from 0 to a. And then you have sine of n pi x by a. And then, yeah. Don't just watch me solve, guys. Yeah, people who haven't done it, please try and do it, because as I said, it's very boring otherwise, right? And then we can have 2 0, sorry, 0 to a, you'll have, what shall I say, ax sine n pi x by a dx, okay, minus 0 to a x square sine n pi x by a dx. Oops, okay, so I've lost something, so let me just cancel it, put dx over here and a square bracket. All right, so this is what we have. So let us just cos this first integral as 1 and the second thing as a 2, okay, and then just go ahead and integrate it. Okay, so somebody else has come in to the, yeah, right, so let's go to the next page. So whoever has the answer for 1, with the exception of Chetan, he of course did it earlier itself, kindly tell me what you've got. Okay, so 0 to a, you have x sine n pi x by a dx. All right, and this essentially is going to be nothing but, I have a minus cos n pi x by a, right, and then I should divide it by n pi by a. This is from 0 to a minus, okay, so this gives me essentially a minus a by n pi, and then I will get a cos of n pi minus a 0 cos of 0, right, plus here I'll get sine n,
Divided by n pi by.
sorry,
Nothing,
did
ma'am.
I miss something?
No, ma'am.
Okay, here is it. Ah, yeah, yeah. Okay. I was going to write it down. I'm sorry. So what do you get now? You'll get a minus a square by n pi cos of n pi plus 0. Right? So this is essentially our uh, first integral. Let's see what we get for the second integral. You'll have a 0 to a. Anybody has already got this answer? Chetan, does it match yours?
Yes, ma'am. First term matches.
Okay. Dx. So this is, mhm. 0 to a, of course. And then we have yeah, minus cosine of n pi x by a divided by, keep this in bracket, dx. Right, so this again we will get a minus a by n pi into, get an a square cosine of n pi minus, I'm just writing the second term as 0. I hope that's all right. Plus 2a by n pi. And then we have, again, we will do this by parts. Integral 0 to a x cosine of n pi x by a dx. I think this is what we had. Where did we have it? We don't have it. Okay, so this is going to be minus a cube by n pi cosine n pi plus 2a by n pi integral 0 to a x cosine x by a dx. Okay, so this we can now take as some integral 3. All right, so let's see what we get for 3. All right, so yeah, so these problems, as you can see, you know, if you're good at integration, which I'm not, all right, it comes out easier. All right, so let's just do the third integral. This is going to be nothing but integral 0 to a x of cosine n pi x by a dx. Okay, and this is going to be nothing but x sine n pi x by a by n pi a from 0 to a. And then you have a minus, okay, I'm going to write it here, minus integral 0 to a. You have sine n pi x by a divided by n pi by a dx, right? So this over here, you actually, your first term will give you a 0, right? The first term is going to give you a 0. And the second term is going to give you, so let me just write it, a n pi. And then you'll have essentially a minus cosine of n pi x by a divided by n pi by a, this whole thing, and you'll have to of course do it between 0 and a. So I don't know about you, but what did I get for this? I essentially got yeah, a square by n pi square, right? It's visible, right? Okay. Into cosine of n pi minus cosine of 0, which is 1. Okay, so please remember that. Yeah. So now let's go and I hope, okay, sorry, I don't know. Is everybody okay till here? Has everybody followed, gotten these steps? Yes? What happened? Everybody's gone off to sleep over.
Yes, ma'am.
Yes, ma'am.
Huh? Okay, great. So,
But I've done it.
sorry, I didn't get you. Please, could you repeat? Okay, I think the audio is, yeah, you're putting it in the chat box. Okay, fine. So 1 second. Do I see the chat box without stopping the sharing of screen? Okay, just let me just finish this and then I will see what you have to say. I mean, is it a doubt of any kind? Okay, I should see the chat box.
Not a doubt, ma'am.
Not a doubt. Okay, good. All right. So let's just finish this off and then we'll get to the chat box. Okay. So essentially, what we then get from for integral 2 by replacing these values is minus a cube by n pi. And then you have a cosine of n pi, right? Plus 2a by n pi. And then you have this a square by n pi. I think you get a square or a cube. I think you get a square. Yeah, square. And then you have a cosine of n pi minus 1. Right? Yeah. So what does Cn then become? Cn becomes 2 of root 15 by a cube into a minus a square by n pi cosine of n pi, right? Minus, actually, Yeah, so then you'll get over here a minus a cube by n pi cosine of n pi. Okay, I may be making some mistakes here, I don't know. A cube, because I'm doing things too fast for my own style. Okay, cosine of n pi minus 2a cube by n pi cube cosine of 0. Okay, or 1. Okay, I should have written it as 1, kind of. Yeah. So if you simplify this finally, okay, what I'm getting is essentially 4 root 15 by n pi cube. Okay, and I get over here a cos of 0. Okay, you can write it as 1, of course, cos of n pi. Okay, this is what I essentially got. So basically, of course, your cos of n pi is going to be 1 when n is even, right? Okay, and it's going to be minus 1 when n is odd. Your cos 0, of course, is going to be 1. So what you're going to get is essentially when n is even, you're going to get a 0. Okay, so Cn is going to be 0 for even n, and it is equal to 4 root of 15 by n pi cube into 2, okay, for odd n. Okay, is this what everybody got? Check it out. Did I make any mistakes? Is it okay?
Okay, ma'am.
Yeah, fine. All right, so this is also what you got, is it, Chetan? Thanks. Okay, so now, of course, our final job is not yet done. What is our final job? We have to write this guy, right? Yeah. So what is this? If you remember, summation over n is equal to 0 all the way to infinity. You're supposed to write Cn e to the power of minus I by h cross ENT. Correct? So this is
N
going,
from 1 to infinity.
sorry, this should be pi q summation of n is equal to 0 to infinity. Sorry, 1. Yeah, you're absolutely right. Very sorry. So now we know that this is not going to be, it's going to be 1, 3, 5, and so on and so forth. You need to do it only for odd ends, right? Yeah. And what will this be? You will have a 1 upon n cube over here. Then you will have a sine of n pi x by a, right? E to the power of, now here you will have minus I by h cross, and then you will write down your, what do you call it? En values. Okay, so what were your En values? I keep, this is nothing but n pi by, oh, I keep forgetting this. This is no good. Okay, so you essentially have to write your ENT, and yeah, I'm going to do something very bad. You are supposed to remember this, and your ma'am has forgotten. Okay, I can sit and derive it again, but that is not the idea, no. So your E is going to be nothing but there's a n square by n a square, of course. So your En, where your En is equal to n square by a square, and as given, I've already forgotten. So essentially you have your h cross square pi square by 2m. Am I right? Is this correct, guys? I don't know. I've forgotten. I hope it's correct. Okay. So that's your En. So you have to put that in and you will get your answer. So this is essentially your answer. Okay. So Let me do a good job at the end. Okay.
It should be multiplied by square root of 2 by a.
Actually, does it need to be multiplied by square root
Sine.
of 2 by a?
Because the science of x have the form of root of 2 by a into sine of n pi by n pi x.
Exactly. But just 1 second. Let me 1 second, Chetan. Yeah. N square by a square. I don't know. I mean, I had this issue last time as well. But if you look at what we have done over here, all right. So let me just go back. All right. So here, when you did your normalization, right? Yeah. You actually
Yes.
took the root 2 by a, isn't it? So do you think we'll need to multiply it again?
Ma'am, as you can you have written psi of x comma t is equal to a summation of in the earlier page, ma'am, which you showed. It's a linear combination of
Yes,
Cn
this
chi
is
n of
correct.
x.
See, this is what I have written, right? Yeah, I
Yes, ma'am.
completely agree that this should be the eigenspace. But now when I actually do the normalization, okay, I've kind of taken this root 2 by a already into consideration, correct? So I have normalized including this root 2 by a. Okay, so this is my contention that you don't need to put it back later. I don't know whether I'm correct, but maybe you do. You know, you're right. I think you're right. Yeah. So we will need to put a root 2 by a. All right. Just think about it. I am a bit confused. All right. Okay. We did normalize using that. So you're saying that we need a root 2 by a over here, right? Okay. So just see whether this is actually required or not. Because if you think about it, I have already normalized here. Okay. Keeping that root 2 by a in consideration. So in some sense, it is rolled into the Cn. That's what I feel. So any other opinions on this? Any other opinions on this, please?
Ma'am, what we have found is Cns.
Correct.
So it should essentially be normalized. But
I feel that it has been organized. So I think the root 2 by a is extra. All right. So we have already kind of, over here, if you think about it, this is, this science star. I mean, what we have done. Okay. We have, or sorry, I mean, over here. Where did we go now? Oh, I have lost it. Fine. No. Yeah, I mean, I feel that it is rolled into the Cn. Is that what you're saying? I mean, who said talk last? What happened? Total silence. Let me stop the share.
Ma'am, chat box.
Yeah, I'll have a look at the chat box. Sorry, Nitin. Yeah, if A was a complex number, Cn would have the complex conjugate of A. Then it would be wrong to not put A for the final answer. Okay, so you are saying that we should put the A. But, we already use the A, isn't it? I mean, like... Okay, so let me just 1 second. I'll have to admit it. All right. Yeah, so how did you calculate it, Nitin? Did you get the same answer? Did you need the root 2 by A?
Yes, ma'am.
Okay, fine. So fine then. I will
Yes,
just...
ma'am. I had put it at the end.
You had put it at the end. Okay. So the question now is, okay, I'll just think about this, guys. Okay. Because I somehow feel that it has already been rolled into the whole thing. So there is no need to add it additionally, but I may be wrong. Okay. Yeah. So I will just re-examine it and I will clarify this in the next class, because I think I had done my calculation without the root 2 by a. So I will just check it out. Okay. I don't have any final place to go and look up my answer either. So I'm sure you guys are right, but we will look it up. Okay. So now let me just share screen once again and show you the next problem. Okay, so this is now something which I'm going to leave it to you guys to do. All right. So please have a look at the fifth problem. Is everybody able to see this, the fifth problem? Okay, a particle of mass. Is this visible? Can everybody see this? Oh, I'm showing you
ma'am.
the PDF document for some reason. Okay, so just 1 second. I have too many things opened up for this class. That's the problem. Okay, let me once again share the screen. I think it was this one that I wanted to show you guys. Yeah, because there's a half. Yeah, so this problem here, the fifth one here, all right. So in this, what do we say? That the particle of mass m is moving in a one-dimensional, infinitely deep square well. Okay. Now suppose at time t is equal to 0, it's wave function. Now what is the wave function over here? It is psi x0 is equal to a into a square minus x square. So please note, here the wave function is different from what you have here, but it's a similar point to start off with. And what does it say over here? That this is going to be the wave function for mod x is less than equal to a, and it is 0 otherwise. Now over here, please note, what is the extent of the well? Can somebody tell me?
Minus a to plus a.
Yes, absolutely right. It is from minus a to plus a. So what is the length of the well then? It is 2a,
2a.
right? So this is the first thing that you should be clear, that while it looks like the earlier problem, here the well extends from minus a to plus a, and it is also, you essentially, the length is 2a. Okay, so this is something that you should be clear of. And then you of course have to proceed in the same way. So what does it basically ask over here? What is the probability Pn of obtaining the value En of the particle energy? Now how will you go about doing this? Okay, so we will essentially I'm going to leave you to do this problem, but nonetheless we will just discuss it briefly once and we will go ahead with it. Okay, so now let me just stop the share and get back to the iScribe. So what we have over here is again the wave function, okay, that you have, psi of x0 is equal to a into, what was it? A square minus x square, right? A square minus x square. And this is of course minus a less than equal to x less than equal to a. And it is equal to 0 otherwise, right? So this is essentially your wave function form, right? Now the point is you're going to do exactly the same thing again. You will write down the psi x0 as equal to summation over n going from 1 to infinity. You'll have a Cn, then you'll have a psi n x. Okay, so this is what you're going to essentially do. Now, remember that what is the probability? So what have you been asked? What is the probability then that you're going to measure energy En? So we'll just go back once again and have a look at that problem. Okay, this time I should be careful to share the right file. I'm doing it again. I'm doing it again. Yes. Yeah. So note again that we are expected to find out the probability of obtaining the value in energy En of the particle energy, right? Yeah. So how will that work out? Essentially, please note, yeah, that links to essentially, so if it is in psi n x, then you will measure an energy En, right? And what is the probability of finding it in the state in the sin x? It is essentially going to be mod Cn square. Okay, so that is the probability Pn. And of course, for this, it is absolutely essential that psi x0 is normalized. Okay, otherwise what will you have to do if you don't normalize it? you'll have to do mod Cn square divided by mod A square. Okay. Yeah, this will be equal to P. All right. So either you can do it either way. You can either normalize it, or you can, what do you call it? You can find out the Cn without normalizing the first wave function, and then do mod Cn square by mod A square. So don't forget, of course, if you start getting answers which, most of the time, these are, you are just going to put in some kind of a representative things. You are going to set up a formula. So you will not know whether it has gone greater than 1 or not. So it's a little dangerous. So I would suggest that you actually normalize it and then do it. Is this clear? Any doubts, please, in this? Does anybody have any doubts? Yeah, that why it is probably better to do the normalization process and then go ahead and find out the Cn's. Okay, and you have to do basically mod Cn square is going to give you essentially the probability value. Okay. So now what else was asked in the same question? Let's have a look. Where is it? It's this one. Right? You were asked also find the expectation value E of the energy. Okay. How do you do that? Essentially, I've given a hint over here. Your expectation value of the energy is nothing but the expectation value of the Hamiltonian. And it will be essentially n is equal to 1 to infinity mod Cn square into En. Okay. So this is how you will get the expectation value of the energy. All right. So please note here, we are not really interested, though it kind of looks like the earlier problem. We are not interested in knowing what is the form of the wave function or what happens to it at time t. Okay, forget about that. What they are asking you is questions about the initial time itself. So all you need to do is to take that form of the wave function, find out how it can be written as a linear combination of the eigenstates, energy eigenstates, and then you have the probability, all right, of a particular energy, and you also have the expectation value of the energy in that initial state. They have really not asked you any questions about how it evolves with time. Okay, so that is not, so that way it is different from the problem that was done earlier. Is this clear? Does everybody have a roadmap to trying and solving this? Yes?
Yes, ma'am.
Okay, so good, good. So just go ahead and try and do it. Are there other people? Do you have any doubts? Shazia, any doubts, please? You're very quiet. Okay, thank you, Zaviula. Amreen, what about you? Tanya, Manikanta? Tell me, we are such a small number, we should be able to, communicate more effectively. All right, Sahana, what about you? Did you get it? Do you have any idea of, do you know vaguely at least a route to trying and solving this problem? Yes,
Yes, ma'am.
Sahana? Okay, good.
Yes, ma'am.
Yeah. So any doubts, please ask. Okay. All right. So now what we are going to do is we are going to go to the next problem where we are going to solve a whole bunch of things. Okay. So let me just first show you the problem. As I told you, what we are going to do with infinitely deep well is that we are going to take it quite slow. All right. So that we get, used to doing these things. And then hopefully when we come to other problems, all right, we'll be able to, other systems basically, we can do the whole thing much faster. All right. So now have a look at the sixth problem, which is what we are going to solve. All right. What does it say? It says calculate expectation value of x, expectation value of px, expectation value of x square, expectation value of px square, and then it has asked you to calculate the uncertainty in x and the uncertainty in px for the nth stationary state. Okay, so here we don't have a linear combination of states at all, we are just having pure states, and what we have to do is we have to deliver the expectation value of these four quantities x, px, x square, px square, and also calculate the uncertainty, right? And then it says check that the uncertainty principle is satisfied. What do you mean by uncertainty principle is satisfied? You have to see that the uncertainty in x and the uncertainty in px is always greater than or equal to h cross by 2. Okay, that's what your uncertainty principle says. And here you have been asked to verify this. And then it has asked you which is the state that comes closest to the uncertainty limit. So you have to see in which particular state uncertainty in x and uncertainty in px multiplied by with each other is closest to h cross by 2. It has to be greater than or equal to h cross 2, but which approaches h cross by 2. Now, I'm going to give you the answer beforehand, and I think some of you already know it. It is essentially going to be the ground state, okay? It is the ground state which will be actually where the uncertainty in position multiplied by the uncertainty in the momentum is going to be the minimum. And this is practically true of every system. In fact, it is true of every system, all right? It is going to be the ground state, which is going to be the minimum uncertainty state. Okay, it is going to be closest to the uncertainty limit. So keep this in your head, please. Okay, because it may come up in context of some kind of a question, paper, or an MCQ, or in an interview context. Okay, this is a very, very important thing to remember, that your ground state, okay, is where the uncertainty in the position multiplied by uncertainty. Yes, any questions, please? Does anybody have any questions to ask? I can hear something, that's what. All right, fine. I'm assuming that it's just going to be some background noise. Okay. So what we have to understand is the uncertainty in position into uncertainty in momentum is going to be a minimum quantity for the ground. Okay, I think somebody has not kept their mic on mute, but I don't understand. Everybody seems to be muted. Okay, maybe. Okay, hopefully this will help. Right. So now let's just get to solving this problem. Oopla. Okay. I think we can do without traffic noise, right? All right. I'm unable to mute. All right. Doesn't matter. So let's now get to, okay, there's something in the chat. 1 second. Have I? Yeah, I agree with you, Nitin. So Nitin has written, I think everybody can see this in the chat box, that the way to check whether this A is indeed needed or not is to check whether the integral psi square is 1 or not, that it is normalized. Yeah, of course. Okay. I just somehow thought that we had already taken that into consideration, which is why I was objecting to its presence there. Okay. But anyway, as I said, let's leave it aside right now. And I will need to think about it on my own. Okay, and then we can get back, and meantime you guys also think and get back on this. All right, so let's move on to, yeah, let me get to the iScribe again. Okay, so what we are going to try and do now is we are going to try, so let me just draw a line across. So this problem, if you remember, we are still going to go with the infinitely, oh, okay, it's because I went off to a new page. What does that mean? Ah, fine. So, yeah, I have drawn a line. Let me just go over the line once again. For some reason, I had changed the page. Okay. So now let us look at this particular problem. Here we, of course, have again the okay, these we know is nothing but root of 2 by a. You can take them, sine of n by x by a, correct? And what we need to find out, okay, is essentially you need to find out x, you need to find out px, okay, you need to find out x square, you need to find out px square. All right, now of course how will we do x? We are essentially going to do from 0 to a. It is going to be essentially x root of 2 sine n by x by a, right? whole square dx. Does everybody get this, how this happens? Okay, this is because of course your x is going to be nothing but, what is it? It's essentially psi x psi, right? Which means it is nothing but integral of psi star x psi dx, right? So here of course you're going to find it in the nth eigenstate, so you'll have to do it for this, correct? Yeah, so we are going to do now, yeah, x, and then it is of course your root 2a sine n pi x by a, correct, star into, sorry, anything I did wrong? Okay, I think somebody really needs to, I really don't know how to mute people from here. More. Okay, doesn't matter. Okay. Okay, just 1 second. Okay, Sandarshan doesn't even have a mic to move. Sandarshan, are you on with us? I think your mic is unmuted. Can you please mute it? Thank you very much. Yeah. All right. So now, of course, this is a real function, so we really don't need to bother with that complex conjugation. So what are we going to get then? We are going to get essentially 2 by a, which will come out as a what do you call it? And then you'll have sine square n pi x by a dx. Right? Yeah. So will you please go ahead and try and solve this now? Give it a shot. Any intelligent guesses as to what this should be? Any guesses? You're trying to find out the expectation value of the position, right? In an infinitely deep well. So any guesses? What should you get expectation value?
0, ma'am. That should be
0, but
constant.
here what are you taking your extent of your well to be? 0 to a, right? So what should you get?
Constant.
Sorry, I didn't get you, Chetan.
A constant.
Yes, it will be a constant, but it is from, basically you're taking it from 0 to a, right? Initially you said 0. I'm saying that the well extent is 0 to a. So what do you think? Think about the wave functions. How are the wave functions with respect to the center of the well? Everybody knows, right, what the wave function looks like for an infinitely deep well, whether it's ground state, first excited state, second excited state. It is a sine function. Take the probability of that. It will be essentially, everything will be positive, right? Yeah. So now think about what do you think the expectation value of the position is going to be? Okay, we'll find out. Fine. Let's just do it. Okay. So can people start solving this? You have to do the integration again. Oops, what did I do? Done something very strange here. Okay, this is a Zoom whiteboard. Okay. I shared the wrong thing. I just doing all sorts of funny things today. Yeah. So people just try and solve this, please. Let me get my own notes up here. This shouldn't take too long. Okay, so the way I solve it, of course, is I just take your sine square of n pi x by a as equal to 1 minus cos of 2 n pi x by a divided by 2. Okay, so this is the essentially what I do, and then it solves out quite easily. So your x will be equal to 2 by a integral x into 1 minus cos 2n pi x by a divided by 2 dx. Okay, I think I'll have to go on to the next page. I hope it won't be a problem. People, I hope you're doing it on your own. Okay, so there's my line which I just drew in the middle of a new page because I changed it on the iScribe. So what are we going to get essentially? So your x expectation value, you will get the 2 and yeah. So essentially the 2 and the 2 will just cancel off. So we'll get 1 by a. And then you will have an integral from 0 to a. You will have essentially your x minus x cosine of 2n pi x by a dx. Right? So your first thing, of course, will be 1 by a. And here you will get and x square by 2 from 0 to a minus, and then you have a integral from 0 to a x cosine 2 n pi x by a dx. Right? So what is going to be the first term? Okay, I need my, so that's going to be essentially you will get a square by 2, sorry, 1 by a into a square by 2 minus 0, right? That's your first term, minus 1 by a, and then we can just write this down. So we have a cosine of 2n pi x by a by 2n pi by a from 0 to a plus, am I doing it right? Yeah. Okay. For some reason, I've written it like this. Okay. I don't know whether this is correct.
I'm actually cos integration of cos.
Yeah. It's a,
But sin m, sin x.
yeah, but I've done it by parts. You have x into cos, right?
Okay, ma'am.
Isn't it? I mean, I don't know. Which one do you take as first into integral or second? Okay, yeah,
Okay,
you're right.
ma'am.
No, have I done it wrong? I think I've done it wrong. So, or maybe I took it as, I don't know. I think I've got it wrong. Okay, so maybe this is not correct. Okay. So anyway, this one you do it by parts, right? The second one. As I told you, I really suck at integration. Okay. So you do this by parts. So that should be, you're right. It should be a sine 2n pi by a by, yeah, you're absolutely right. Okay. And then you will have, so I will get over here a by 2, and then I'll get a minus, and then what should I get? First into integral of second, right? So this, so that will be 2n pi x by a divided by 2n pi by a. There should be a minus sign. I think so. 0 to a, then minus integral of from 0 to a will be again differential of first. Okay, I think I've completely botched it up. But the basic thing is that, okay, somebody tell me what the answer is. The answer should be actually just a by 2. Okay, I for some reason this integration, I'm not able to do it at the moment, which is a stupid thing to say, but that's how it is. So has everybody got a by 2? Anybody? with the same answer? Your second term should actually fall off. It should just go to 0. Still solving?
Ma'am, we get a by 2. Is that because it has a maximum? I mean, the wave function goes that way.
Yeah, so the basic thing is this. Okay, so let me explain with the ice scribe. What's the time? Can anybody tell me what's the time, please? So I don't want to overshoot.
2 o'clock.
Oh, it's 2 o'clock. Okay. So I will just explain this one thing and then I will stop. Okay. I will just, so please think about what is your wave function. Okay. So if you think about, so this is, let us say 0 and a, or it could take it from minus a to plus a, it doesn't matter. Let's draw this. Okay. And then you know that the ground state, okay, whatever it is, all right, it's essentially like this, correct? Then you take, so this is going to be, this is E1 and then E1. Okay, so let's, I'm just doing it a representational way. There's no sense in doing it like this actually. But then you have this, right? And then this is E2, of course. And then that's 4 times E1. And then you have 5, 6, 7, 8, 9. And then that will be your third guy, right? Okay, now what you should realize is that it's perfectly symmetric about the this thing, about the center of the well. It's perfectly symmetric about the center of the well. All right. And if it is perfectly symmetric about the center of the well, the expectation value of the position is always going to be the center of the well. So no matter which state you take, all right, please think about it. Okay, so if you want to do the probability, for instance, for this, it will just go like this, right? Yeah, for this, it will go like this, right? There'll be 3 bumps, isn't it? So they are perfectly symmetric about the center of the well. But just from a symmetry argument, okay, you should be able to realize that the expectation value of the position is always going to be the center of the well. Is this clear? So this is without, trying to solve it. So that is what I said, that we will do formal solutions. We will also learn tricks. So this is a trick I'm telling you, that you don't really need to go ahead and solve for the expectation value of x if you realize that the wave functions are invariably symmetric about a certain point. If they are symmetric about the certain point, position expectation value is always going to be that particular region about which they are symmetric. So which is why when Chetan said 0 initially, okay, if the well had gone from minus a to plus a, he's absolutely right. It is 0. Okay. On the other hand, since the well is going from 0 to a, you have to be a bit careful. It is a by 2. Okay. So please note which is the center of the well, depending on the dimensions. Okay. The extent of the well. So if it's minus a to plus a, obviously it is going to be x is equal to 0. If it is from 0 to L, it is L by 2. If it is 0 to A, it is A by 2, and so on and so forth. Is this clear? Okay. So we will get back to this in the next problem, next class. And in the meantime, I'm going to send you simpler, more numerical kind of things in the infinitely deep well. All right. Not all of them I will want you to submit. Some of them I will expect you to solve on your own, and I will send you the solutions as well. Solutions in the sense, the answers. Okay. So if you have any issue with the answers, you can get back to me. All right, so we will stop here because I know you have a class again at, in an hour's time. So, all right then, any doubts? Sahana has raised her hand. Oh no, that's my own mouse. I'm sorry about that. Sorry, Sahana. Okay. Again, let me tell you that if there are ways in which you can think the whole interaction session can be improved, we can do that. Okay, so I'm open to suggestions. Right? Okay then, so I will stop the recording here.